A particle is traveling in a medium and a photon is traveling in vacuum. We need to find the ratio of the wavelength of the photon to the wavelength of the particle. Okay, so let's write the ratio. So wavelength of the photon divided by wavelength of the particle. So that is what we need here. Okay, so how do we get the wavelength of the photon? It is h, Planck's constant, divided by the linear momentum. Again, for the particle, de Broglie gave the wavelength of the particle is also identical to the wavelength of the photon, right? So that's his great contribution. So h by linear momentum. That's really fantastic how he came up with that. So h by p. Here the linear momentum of the particle, we can write it as mass into velocity. So m into v. So now this becomes mv by p. Okay, so just substitute the values here. Mass of the particle is 9.1 into 10 to the power minus 31. The velocity of the particle is 10 to the power 6. Now this p is linear momentum of the photon, which is 10 to the power minus 27. Okay, so what do we have here? I think the numbers are nice. So in the numerator we have minus 31 plus 6, so that would be minus 25. If the powers of 10 goes upstairs, minus 25 plus 27, that's 10 to the power 2, so that is 910. Okay, so the wavelength of the photon is 900 times the wavelength of the particle.